We left off yesterday talking about how to solve one and two-step equations, and we were talking about how we isolate the variable. And I want to make it clear that we do this. We do the variable term first. Whatever term has the variable in it, that's what we're going to get by itself first. And then the variable. So I'm going to write then the variable. Okay, and a couple of other things because today's problems are going to be just a little bit different. And I do want to make sure that we're clear on what makes a solution to an equation. So yesterday when we left off, we got these answers right here. What makes the answer to problem D the correct answer? Does it actually work in the equation? Well, like I did yesterday, again, the point of solving an equation is to get the variable on one side by itself so you can read off the answer. And the whole idea there is the answer or the solution is what you can plug into the equation to make it true. So I'm going to do this. I'm going to plug that in right there and watch what happens. We have 10 minus 4 times this would be 12, and then that should equal negative 38. Oops, negative 38. So we have 10, and then this is going to be negative 48. We're hoping that equals negative 38. Again, these are different signs. We find the difference. The difference is 38. The bigger one is negative. So this is negative 38 equals negative 38. So it's definitely true. It checks out. That's the right solution. A couple of other things that we ought to keep track of that are important when we're solving equations, especially if we're dealing with rational numbers. Remember, rational numbers are numbers that can be written as fractions. So they're either fractions themselves or they can be turned into fractions, and we're going to talk more about that this year. So if there's a fraction in the problem, you might as well think of everything else as a fraction. You can take any number and you can turn it into a fraction. So if I take the number 6, you can turn 6 into a fraction by putting it over a 1. If you wanted to take a variable and turn it into a fraction, if I had the variable y, you can put it over 1. So if it's not already a fraction, you can turn it into a fraction. So good thing to keep in mind there. And then I'm hoping some people remember this. How do you get rid of a fraction in front of a variable? So when we're solving an equation, a lot of times we're going to have a fraction in front of a variable. Well, in order to get rid of a fraction in front of a variable, we multiply both sides by the reciprocal. And we talked a little bit about that before. We're going to do a bunch of that today. And then when is it okay to write the answer as a decimal? So you're solving an equation and you think, oh, my calculator said it was a decimal, so I'm just going to go ahead and write that down as a decimal. Well, as a general rule, especially in this class, the only time you're going to write the answer as a decimal is when the problem is written with decimals. Written with a decimal. When the problem's written with decimals, that's your permission to write the answer as a decimal. So let's go ahead and take a look at these problems right here. Now, remember, we're trying to isolate the variable, but we're going to do that by isolating the variable term. We've got this fraction bar right here, and fraction bars are unique. They represent division, and the way they're written there, it's an exception to the order of operations. So what I'd like you to do is, this fraction bar, those horizontal bars, they are actually grouping symbols. So I'm going to put a dotted circle around this right here. That's what we're going to keep together. We're going to keep the top together with the x plus 4. We're going to get rid of the dividing by negative 5. So we're going to multiply this side by negative 5, and we're going to multiply this side by negative 5. Those are going to cancel. We're left with an x plus 4 over here. We end up with a 3 times a negative 5. That's a negative 15. And then we're going to subtract the 4 from both sides. When we subtract the 4 from both sides, that's going to get the variable completely by itself, and we end up with a negative 19. So x equals negative 19 is the answer to that one. So we'll move on. Again, the difference between this one is, notice that this long fraction bar groups the x plus 4 together, the x and the 4 together. On this one, this is a short fraction bar, so that negative 2 is off there by itself. So this is the variable term. So I'm going to circle that guy right there. And what we want to get rid of is we want to get rid of the subtracting 2. So of course we're going to add 2 to both sides. I'm going to go ahead and cross that off. This is going to give me, well, let's see, negative 2.1 plus 2 is negative 0.1. Then over on this side, we have x over 9. We're going to continue solving this. The only thing left we have to undo is this dividing by 9. So we're going to multiply both sides by 9. Multiply each side by 9 here. Those 9s cancel. I get an x over here. And then on this side, we have 2 times negative 0.1, that's going to be negative 0.9. So we're going to circle that, and that is the answer right there. And again, a lot of people struggle with figuring out the difference between the two of these. This long fraction bar groups the two of those on the top together. That short fraction bar just groups the top and bottom together, so we're going to get rid of the negative 2. So you'll notice that we've got a short fraction bar right here. So this is what we're going to get by itself. We're going to do that by getting rid of the 9.2. So we're going to subtract 9.2 from both sides. So this is going to be y over negative 3, and then on this side we have negative 9.2. We're going to get rid of the dividing by negative 3 by timesing by negative 3. Remember, we've got to multiply by a negative so that it cancels that off. We want that negative to cancel off that negative. Negative divided by negative is a positive. So those cancel off, so we end up with a y over here. And if I multiply that side by negative 3, a negative times a negative is a positive. And I believe that's going to end up being 27.6. But let's just double check to make sure we got that one right. So I'm going to clear this off. And we're going to do negative 9.2 times 3. Whoops, negative 3. Go back there and put that in, negative 3. And we get 27.6, so we're in good shape there. This next one is kind of interesting for a couple of reasons. I am going to do this one with the bars right here. So notice that this, including the sign, that's the variable term. So we're going to get rid of this by adding 1 to both sides. So I'm going to add 1 over here. That's going to leave me with a negative a, and I'm going to write the equal sign. I'm just going to follow that right down here. And then I have negative 1.2 plus 1. Well, negative 2.2 plus 1 is going to be negative 1.2. And now some people sometimes they just ignore that negative, they forget about it, and they say, oh, that doesn't matter. But remember, the opposite of a is negative 1.2. Well, we don't want the opposite of a, we want plain old a. So there are a couple things that you can do. You can divide both sides by a negative. That would take care of it. Divide by negative 1. You could multiply both sides by a negative 1. And in either case, if we multiply or divide by a negative times a negative is a positive. So we have an a over here. And a negative times a negative is a positive. So we get a positive over here. So we get a equals 1.2. There are several ways of dealing with that. That's one. Let's take a look at a few more. Notice the long fraction bar. That groups the two of these together. So we're going to get rid of the 2 by multiplying by 2. So this is going to be 5 plus b over here. We get a negative 8. We're going to get rid of the 5 by subtracting 5. So we end up with b equals negative 8 minus 5. Same sign, find the sum. Sum's going to be 13. Keep that same sign. Double check on your calculator if you'd like to. But there we go with negative 13. Now, this one, we've got a fraction in front of the variable. And this is what we were talking about. You'll notice that there's only one step that we need to take care of here. We need to get rid of multiplying by 3/4. Well, we would normally divide by 3/4, but remember, we don't divide by a fraction. We always flip that over and multiply. And notice the advantage that we've got right here. If I multiply by the reciprocal, and reciprocal is a fancy word for flipping a fraction over. If I multiply this side by 4/3, I've got to multiply this side by 4/3. So the 3 will cancel with the 3, the 4 will cancel with the 4, and I've got an x. In one step, we've got the variable all by itself. Now, take a look over here. I'm going to change colors so we can cancel these off. Let's see, we've got a 9 and a 3. 3 goes in here once. 3 goes in here 3 times. We've got a 4 and a 10. Let's go ahead and do this cross cancellation, because then we'll be right at the answer once we multiply. 2 goes in here twice. 2 goes in here 5 times. So if we multiply those numerators together, 3 times 2 is 6, and 5 times 1 is 5. And you'll notice that that's a reduced fraction. If we had multiplied these together, we would have gotten 36 over 30. And then we would have had to factor out a 6 out of both of those. 6 goes in there 6 times, 6 goes in there 5 times. It's the same answer, we just got it a different way. Much easier to cross cancel. That's going to be a really good skill in the long run. Okay, let's take a look at these last two here. I'm going to blow this up just a tad so we can take a better look at these. So on this one right here, again, this is the variable term, which means we're going to want to get rid of that plus 1. So we're going to subtract 1 from both sides. I'm just going to move it to the other side there. We're going to have 2/5 x equals 7 minus 1 is 6. Again, we've got that fraction in front of the variable, so we're going to multiply by the reciprocal. So we're going to multiply by 5 over 2 on this side and multiply by 5 over 2 on this side. Now remember when I talked about writing everything as a fraction if there's a fraction in the problem? That's going to be useful right here. So we're going to put a 6 over 1 there so we can match up numerators and denominators. 2's are going to cancel on this side, so you'll notice that we have the x right there. And then again, I'm going to change colors for just a second. I can't cancel the 5 with anything on the bottom, but notice what I have here. 2 goes in here once, 2 goes in here 3 times. So the only thing left on the bottom is a 1, and the only thing left on the top is a 5 and a 3, which multiply by 15, or to be 15. We don't need to write 15 over 1, we can just write plain old 15, and that would be the answer. So that's how you handle a problem like that. Again, that multiplying by the reciprocal, really good technique, and that thinking of everything as a fraction when there's a fraction in the problem is a good thing to keep in mind. All right, this is probably the most challenging one on here. Notice that everything in here is a fraction. Now I'm going to deal with this without a calculator, and then I'm going to go back and just double check and make sure. Again, this is the variable term right here, so I want to get rid of the 5/8. I'm going to cross it off from this side, and I'm going to add 5/8 to both sides. I can make a common denominator here pretty easily. This is 4/8 plus 5/8. So this is going to be 9/8 when I put those together. Remember, the denominator is the size of the piece, so that doesn't change at all. I have 4 of these pieces plus 5 of those pieces, so altogether I have 9 of those pieces. And then we've got negative 3/8 x. We're going to multiply by the reciprocal, so I'm going to multiply by negative 8/3. Again, we need that negative to cancel those out, so I'm going to multiply by negative 8/3 over here. So negative cancels with a negative, 3 with a 3, 8 with the 8, so we end up with an x. And then over on this side, take a look at what happens here. Again, I'll change colors for this one. 3 goes in here once, 3 goes in here 3 times, 8 goes in here once, 8 goes in here once. So the 8's cancel, they turn into 1's, and then the 9 over 3, that turns into a 3. Now, the thing you've got to be careful of, 3 times 3 is 3 times 1 is 3, 1 times 1 is 1. We don't need to put the 1 in the denominator, but don't forget that little negative right there. Remember, this side was positive, but we multiplied by a negative, so the answer on this one is negative 3. All right, let's zoom out and take a quick look at what we've done here. Those are the type of problems that you need to be able to solve. These are going to be fair game for a quiz or a test. You got to make sure you know how to do these types of problems. These are the building blocks for everything else that we're going to do this year. So really well worth your practice. If you understand it already, it's just practice. If you don't understand it, please make sure you get some help, ask some questions. Make sure that you know how to do these so that we can move forward this year and you can be in good shape. All right, good luck.